So, have you noticed how the entire conversation around AI has just completely shifted gears lately? We're way past the days of just talking about some chatbot sitting in a web browser writing our emails or summarizing long articles for us. We're actually standing right on the edge of this massive leap toward artificial intelligence that acts, moves, and literally navigates the physical world around us. But behind all the glossy presentations and those wild trillion-dollar valuations, what is actually happening on the ground? Welcome to today's Explainer, where we're going to unpack the true state of the AI frontier. We'll look at the mind-blowing infrastructure being built, the ambitious systems being designed, and, crucially, the very real speed bumps the tech industry is hitting as it tries to drag these visions into our messy, real world.
Here's our roadmap for today. We'll cover the next AI frontier, powering the infrastructure, the rise of agentic AI, physical AI and robotics, some much-needed industry reality checks, and finally, the road ahead. Let's jump right in. Section 1. The next AI frontier. Let's quickly establish what this next generation of AI actually looks like, cutting right through the buzzwords.
There are two major categories completely taking over the tech world right now. First up, you have agentic AI. Think of this as software that doesn't just sit there waiting for you to type a prompt. It's designed to reason, plan out multi-step processes, and take action autonomously to solve complex problems. Then you've got physical AI. This is the wild stuff where the digital brain actually meets the real world. Robotics, autonomous machines, edge computing. We're not talking about minor software updates here. These are entirely new computing paradigms.
Section 2. Powering the infrastructure. Now, to make these incredibly complex AIs actually work, you need an absolutely insane amount of computing power.
Just to put this into perspective, look at this number, 81%. That is the chunk of the top 500 supercomputing list powered by just one single company's tech, NVIDIA. We're talking about the backbone for over 400 of the fastest computers on the planet. The sheer scale of the hardware being deployed right now is just staggering, and it's almost all flowing through one giant technological ecosystem.
Breaking down this super dense ecosystem, at the very top, for that massive supercomputing power, you've got architectures like Vera Rubin and Blackwell. These are basically the engines for what the industry is calling a new industrial revolution. But then, as you zoom down to the physical world for robotics and edge computing, the stack shifts. You get specialized platforms like Cosmos 3 for foundation models and the Jetson and Isaac platforms for autonomous machines. It's an interconnected web of hardware built for totally different levels of AI execution.
And we're literally watching this evolve step by step. We started out with standard, everyday data centers. Then we had to rapidly beef up AI storage and cloud capabilities just to handle the massive data sets for training. Now, we are straight up entering the era of dedicated AI factories. These are giant facilities optimized for one thing, churning out AI tokens at the lowest possible cost per megawatt. We're even seeing sovereign AI grids woven directly into telecom networks to distribute this computing power globally. The whole infrastructure is just mutating before our eyes.
Section 3. Rise of agentic AI.
So, we've built the supercomputers, but what are they actually running?
Well, AI is shifting from being a passive assistant to an active participant. With tools like Nematron 3 Ultra and BioNeMo, we aren't just asking a machine to, summarize a PDF anymore. We're handing over complex scientific research and entire telecom network management to autonomous agents. These systems are being built to just run 24/7, reasoning through problems, tweaking their own parameters, and knocking out highly technical workflows without a human ever stepping in. That is the real promise of agentic AI.
Section 4. Physical AI and robotics. Because as wild as the software side is, the leap into physical hardware is where things get truly mind-bending.
Let's compare two totally different ways physical AI is hitting the market right now. On one hand, you have the Cosmos 3 Omni model. This is an open-world foundation model meant to give general industrial robots the ability to reason, run simulations, and then physically act inside a factory setting. On the other hand, look at Drive Hyperion. This is a hyper-specialized, Level 4 robotaxi-ready platform made strictly for full self-driving cars. One is all about general adaptability in an enclosed space, and the other is laser-focused on hyper-specialized safety out on the open streets. And guys, these aren't just sci-fi concepts on a whiteboard somewhere. These exact tools are being aggressively adopted by huge industries right now. We're talking healthcare and life sciences using BioNeMo, and automotive jumping on Drive AV. In climate and weather, platforms like Earth 2 are running massive global simulations. And in manufacturing, digital twin technologies like Omniverse and factory blueprints are completely revolutionizing how assembly lines work. It's an across-the-board push to digitize the physical world.
Section 5. Industry reality checks. Because despite this massive build-out and bold vision, deploying these systems into the real world is turning out to be incredibly tough.
Check out this recent headline. When Meta's Mark Zuckerberg is telling his staff that AI agents just haven't progressed as quickly as he'd hoped, that is a pretty serious reality check. It shows that despite pouring billions and billions of dollars into infrastructure, these software agents are hitting some major speed bumps. Getting an AI to reliably reason and act over a long stretch of time without just hallucinating or breaking down is an enormously difficult computer science problem. And honestly, it hasn't been fully solved yet.
And the reality check is even harsher in the physical world. Just look at this. Legacy automakers like Ford are actually having to bring back veteran human engineers, the so-called graybeards, because the AI tools just couldn't cut it yet in certain engineering and development tasks. The real world is full of friction, edge cases, and total chaos that a computer simulation just can't always predict. At the end of the day, human experience still matters deeply.
Section 6. The road ahead. So where does all of this actually leave us? Well, the tech industry is fully aware of this reliability gap, and they are scrambling to bridge it. Right now, there is a massive focus on building functional safety systems. A great example is NVIDIA's Halos, which is designed as a full-stack safety system for physical AI and robotics. Before we can have humanoid robots walking around our homes or autonomous factories running entirely on their own, we need rock-solid guardrails. The tech has to be undeniably reliable and safe, and building those protocols is the biggest hurdle right now. I'll leave you with this final, provocative thought for today's explainer. When you look at the sheer speed at which these AI factories and supercomputers are being built, it is breathtaking. But can the actual rollout, the reliability, and the safety of the AI tools themselves ever truly keep pace? We are building the most powerful engines in human history, but we're still trying to figure out how to steer the car. Thanks for hanging out with me on this deep dive. Keep questioning the hype, and I'll catch you in the next explainer.